All right, we are doing some transformations. This is this first section here, translations and reflections, kind of going together. So first of all, a transformation, that is a change in position, size, or shape of a figure. And actually, sometimes you can change the orientation of the figure. Got two things here. Pre-image, this is the old figure. Always call them the old or the new. And then the image, that's the new figure. Okay, you got different types of transformations. A rigid transformation is a transformation that preserves distance and angle measures. So essentially what that means is it keeps your shape congruent right there. Now, as soon as you start messing with like the scale factor and stuff, that's going to change your like your angles, or maybe not even your angles. It might even just change your side lengths there. So rigid transformation, congruent. The main one we're going to be talking about today is a translation, and that maps all points of a figure the same distance in the same direction. A good word maybe for this is shifting. So like shift up, down, left, or right. Okay, orientation, you heard me use that word earlier. The order which the vertices of a figure appear in either clockwise or counterclockwise direction there. So like reversed orientation would be something like this here. If I had A, B, C, and then you had a second triangle where the orientation's reverse around, it'd be A and then B over here on the right hand side and then C. So that'd be reverse orientation. So we'll talk about reverse orientation versus same orientation in just a moment. Or actually, that might even be tomorrow's lesson. Composition of transformations, that's a combination of two or more transformations. And I think that comes up a little bit later into the unit. All right, a transformation blank every point of a figure onto its image. A transformation maps. Okay. All right, and then we use this thing. It's called prime notation to identify the image point. So, for example, we're going to have like triangle, maybe like ABC, and then we're going to map it on to a new triangle, and then we're going to give all the new points a new name. And it's like this: A prime, B prime, C prime. It's basically like a little apostrophe above each one of those. And this right here is the new figure. Okay, coordinate notation. So this is how this looks right here. For translations, you're going to put a capital T. You're going to put a little subscript right here, and you're going to say, maybe for example, like 4 comma and then -2 right there. And you're going to do that to each x comma y point right there. So each order pair, you're going to move it in a certain direction right here. And then this right here, what this one specifically means is the x right there, that's going to be going towards a positive direction. So that's going to be going right 4 and then down 2 units. All right, now sometimes you'll see this, a mapping. I think this is the way the old geometry textbooks had it, is you say you just take an x comma y and then you go x plus 4 and then y minus 2. And those would be, that's more of a mapping. I think we use, at Flower Mound High School, we use the coordinate notation just a little bit more. This stuff right here, sometimes you'll see it with just the brackets without like the t and the x comma y, and those are called vectors usually when it's written like that. So sometimes we'll see vectors. Okay, properties of translations. All right, remember this is shifting. So shifts. So that means that you're going to have the same orientation. And then also it's rigid, which remember that means everything's going to be congruent. Angles and side measures don't change there. Okay, so this first part here is just practicing using a vector right here. So it's pretty straightforward here. It looks like it's saying take a point, move it down 1 and over 1, and then we're going to go ahead and do that with each of these vertices here. So usually you want to do vertices and move those, and we're going down and down one, and then I guess right one. So there's that point, there's that, and then there's your new figure. And actually, I guess if you wanted to create a three-dimensional figure here using your vectors, you can connect those lines right there, and then I guess it makes a cube. So this right here, this notation says go up 2 and then over to the right 1. So I'm going to do that with each of these points right here. And then you got this triangle going on right there, and then I guess if you connect all your points, you got what looks like a triangular prism. Okay, what is the image of A under the transformation or the translation to and then 1 right there? So we're going to look here at A, and then we're going to go this notation. We just got to understand what that means. That means left 2, and then the positive 1 means up 1. So we're going to go left 2 and then up 1. That'd be at point B right there. Okay, what if we go from A, but then we do it a little different? I guess this says right 1, but then the minus 3 means down 3. So right 1, down 3, that would be over there at C for that one. All right, now let's take C, and then we will go translation, and then that'll be right 5, and then up 2. So where are we starting again? C, right 5, 1, 2, 3, 4, and then up 2. That'd be point D right there. And then what is the image of C under this right here, which means right 1 and then up 4. So taking C, right 1, up 4, that happens to be B as well. Now sometimes you'll just write these as order pairs, like that last one there you would have written as, I guess, 0, 3. So sometimes they'll give you letters for them, sometimes you'll just have to write the letters on your own. So now 7, 8, 9, 10, these are kind of like the same thing, except now we're going to write the translation. We're going to write this notation right there, the T, and then which directions we're going, and then X, Y. Do that to each point. So what are we doing to get from B to D? And usually you go with your X stuff first. So left and right. So that looks like we're going right 4 and then down 1, 2. So we're going to say translation, get your vector of right 4, so that's positive 4, and then down 2, which is negative 2. And then you do that to each X, Y. What are we doing to go from B to E? All right, now this one here is kind of interesting. You're not going left or right at all, but then you're going straight down, and it looks like 7 units there. So we can't just leave nothing for X, so we're going to put a 0 as kind of like our placeholder. And then negative 7, that's the vector, and then X, Y. That's just all kind of like the notation there. What are we doing from D to F? Now this one's kind of weird because we're going backwards. We're going backwards 1, and then we're going down 1, 2, 3. So this one here, you're actually going to go negative 1, and then negative 3 for down 3. And then going from D to E, going backwards quite a bit now this time. So be careful with their counting. I think, yeah, so backwards 4 and then down 5. So left 4 and then down 5. And then you do that to each X, Y. All right, let's see what we got here. Graph or find the image. So find the new, given the translation and coordinate notation there. So we're going to take this figure right here, and then we're going to do all of the stuff there going on. So let's do this here, negative 3, 2. So that means, I guess I'll write it out here. That means you're actually going left 3, and then you're going to go up 2 with each of the points. So I'll start here with H. I'm going to go left 3, 1, 2, 3, and then up, I think we said 2. So here's where your H prime will be. Okay. Your next one here, I guess we'll go ahead and do G. So we'll go left 3, 1, 2, 3, and then up 2. So I think up there at 4. We'll call that G prime. And the same thing with I, left 3, 1, 2, 3, and then up 2. So that'll be right there on your x-axis. And that'll be, I guess, I prime. Then I'm going to go ahead and connect my points. And this should be the same figure here. It should look like a congruent shape. That's how you do that one there. And you don't have to connect all the dots there. I guess that was what they wanted us to do on this first example. Usually you don't. Alright, find a translation that has the same effect as the composition of transformations here. So notice here you got two different things. We're essentially combining them here. So this means right 4, but then this means left 1. So really the easiest thing to do is just go and do 4 plus -1, which gets you 3. Alright, so then we're going to say the translation, and then that's a total of just going right 3. And then you go do the same thing for y. So essentially just add your two numbers up. 8 and then plus 6 there. So that's right 8 and then that's right 6. So that's a total of right 14. And we do those little bracket things. And then you go x comma y. Alright, so this one here, kind of the same thing, different numbers, 2, -3. If I combine those, that'll be -1. So you're just adding them. And then you got 4 and then 1 right there. So you add those up, you get 5. And that's it there for that section. So that's all your translations right there. Now we're going to talk about reflections. And there's a couple of properties of those. Now these will be kind of similar, except your orientation, when you reflect, it actually is going to reverse the orientation. But it stays as a rigid figure right there. It means all the side lengths and all the angles should be the same. Okay, now there's a couple different ways you can do this here. You can think about it logically, and sometimes you can change the points. I always like to use a graph to kind of help myself out here. So this first one here, R and then x-axis, that means reflect across the x. Across the x-axis. So first of all, label your x-axis. This point here, 3, 2, needs to be the same distance from the x-axis here. So if you look here, it's about 2 units away from the x-axis, so then go about 2 more down, and then that would be a mirrored image across the x-axis. And you'd say 3, -2 for this one. Now some people memorize the rules. If you reflect across the x-axis, it changes the sign for the y-coordinate, and then if you reflect across the y-axis, people know that changes the coordinate of the x-axis. But I don't necessarily remember that. I usually just use a graph, or I just take a second to think about where it should be. So like this one here, 1, 2, 3 units away from the y-axis, so then go 3 more units away from the y-axis, and then that'd be -3, +2. So like I just said, you change the x coordinate there, and they change the signs there. So 3, 2, and that would be point k prime, I guess, again. Or sometimes they'll put like double prime for second transformation there. That's really it there. So let's do a couple more. Now these here are with the whole shapes here. Here's what you're reflecting across your x-axis. So it should look the same exact thing. Should look like the same exact thing across the x-axis here. So I just go and count how many units across here. So I start out with E. Doesn't matter which one you start with. That one's 4 units away. So then go 4 down right there. Or well, if I can count correctly, I put that in the right spot. And then there's where your E prime is. Go do the same thing with F. F is only 2 away, so then 2 more away. I'm going to put a point right there. And usually I don't even draw these lines here. I'm just doing that so you guys see where everything comes from. My notability here. D is only 1 unit away, so then 1 more unit away. Put a point down there to, -4, -1. There's your D prime. Then connect your shape. Alright, and then I always go back and look. I actually tilt my paper to where where I can see if it's the same thing, left and right. So it's kind of hard to obviously do that on the screen here. But anyways, if you tilt your head, you can kind of see everything's the same along the x-axis right there. So that's a reflection right there. So let's do a reflection across the y-axis here. Same figure, I guess. So now we're counting how far away from the y-axis we are. So F right there is 2 units away, so F prime will also be 2 units away. Alright. I guess D is 4 units away, so then 4 more units away. You're going to put D prime. And then Y right there is only 1 unit away, so go 1 more unit away. You put E prime. And by the way, I can't remember if we do see an example here in a moment, but if you have a point that's directly on the axis that you're reflecting across, you don't move that point, it just stays on there. So like if E happened to be right there at that point, you would, when you reflect across, it doesn't necessarily move. So there you go. Now I got a couple of these weird examples here. Because like this one here, reflect across the line x equals 1. And we got to remember here that's a vertical line. So x equals lines are vertical, and then y equals lines, like y equals 2 is a horizontal line. So that's a good little remembrance thing there that you need to have. So we have these points here. I'm going to call them A and B since they didn't give them names. So 2, 3. And that's A, and then 5, 8. So A and then B, and then I'm going to reflect A, B across the line x equals 1 right there. So that means x equals 1, that's a vertical line, and it goes through 1. So I'm going to draw myself a dotted line. Usually a dotted line is a good line to draw so you don't get yourself confused on what the actual shape is. So we're reflecting across that line there. So this is where you got to be careful. We're asking ourselves, how far away are we from that line right there? So right over here, A is 1 unit away from that line, so you're going to go 1 more unit away. So A prime will be down there. And then B prime, I'm counting 1, 2, 3, 4 units away. So go from the line, 1, 2, 3, 4. And then there's B prime. There you go. Now these next two here are your special cases, and these are a little bit harder to do with these lines because they're reflecting across diagonal lines. So the way I do this here, I memorized a rule for these here. When you're reflecting across y equals x, since those are the same there, essentially what you're going to do is you're going to switch the order. That's our rule for that. And I'll kind of show you why, I guess, here. So I'm going to do a dotted line here. Actually, I'm going to make it straight because I can do that here real well with Notability. So there we go. So there's the line y equals x. That's basically, going through the origin and then up 1 over 1 from there. And then what do we have here? I guess we got -4, 2, and I'll call that A, and then 3, 5. So -4, 2. There's A, and then 3, 5. So 1, 2, 3, 5. All right, and then now that we have those, we're going to take those and reflect them across y equals x. So our rule is to switch the order of the order pairs. So A prime, you're going to take -4, 2 and switch the order. So that'd be 2, -4. And then B prime is going to be 5, 3. And we'll go ahead and plot those points. So 2, -4. Here's your A prime. And then you have 5, 3. And there's your B prime. And that's probably the best way to figure out how to graph those points and plot those points. You could count diagonally how many units away from that blue line that you are. So A is about, I guess, 1, 2, 3 diagonal units away, so then 3 more diagonal units away. You could say A prime is there, and then B is 1 diagonal unit away, but that's, sometimes when you get to half units, it kind of gets a little bit tricky there. So I would just memorize this thing about switching the order on those. All right. And then here we go. This one here is a little bit different, except now we're reflecting across the line y equals negative x. So I'm going to go ahead and sketch that line here. So there's that line, and then let's see what points we're dealing with. We have 2, -1. I guess I'll call that A. And then B will be -4, 5. All right, and then I guess we're going to take those and reflect it across this line with a negative slope. Now the rule for this one right here, it's also going to be switch order, except since there's that negative, you're going to be doing something here with the sign. So you're going to switch the order, and then also you're going to switch the signs. That's kind of our trick there for that. So A prime right here, not only are you switching the order, it's going to be, 1 comma, some of you guys are going to say -1, 2. That's switching the order, but then you got to go change the sign. So it's actually +1 and then -2. So that would be down there, A prime. And then B prime, same thing, so switch the order, 5, -4, but then change the sign. So -5 and +4. -5, +4, right there, B prime. And then there's your 2 lines right there. And then it should look like a reflection. Always go back, take a step back. Does that look like a reflection across that line? This one definitely does. If you want to do that little trick here, but as far as counting diagonals, B prime is half a unit away, or half a diagonal away, and then A prime is half a diagonal away as well. But once again, counting the diagonals, that gets really tricky quick. So just memorize those 2 rules. That's one of the few things you'll need to memorize from this unit, and it will make your life easier. So that's our lesson on translations and reflections.